Okay, so what I want to talk about tonight is the phase shifts and also the vertical shifts. Phase shifts are really just horizontal shifts. We called them horizontal shifts, and all of our other functions in a trig function has a special name, phase shift. In a quadratic or an absolute value or any other function, the horizontal shift was represented by h, and remember we subtracted it from the x coordinate. And so for the phase shift, depending on the book, you're going to see it look like this. This plus c. And just realize that the phase shift is going to be the negative of c. Now, this b, this is an interesting piece. We already talked about the fact that a represents the amplitude, so the leading coefficient is the height. The b is the frequency. So the multiplier on the actual angle itself is called the frequency. And the higher the frequency, the more often the graph repeats. The lower the frequency, the less often or the more stretched out it becomes. The negative of the c then is going to be your phase shift, but the frequency affects the shift, and that's a piece that's really important. At this level, as far as the curriculum goes, supposedly, if there's a phase shift, there will not be a frequency manipulation. And if there's a frequency manipulation, there's not supposed to be a phase shift. They're not supposed to give you both of these at the same time at this level. I am going to show you how it works, though, just in case. And then, of course, D is the vertical shift. Okay, so here I have a function, y equals twice the sine of x minus pi over 2. I'm asking you to graph one period of this graph, or one complete cycle. And so it's actually easier to graph a period than it is to graph over an interval. And let me just show you exactly how we set it up. Okay, on this particular graph, my amplitude is 2. And so it's going to peak and valley at 2 and negative 2. My frequency is 1. And so I know then that my period is equal to 2 pi. Because period is 2 pi divided by frequency, and because the frequency is 1, remember that's the coefficient on the x. Now I do have a phase shift, and we just abbreviate that PS. Phase shift, because it's a minus pi over 2, remember I take the negative of that term. So the phase shift is going to be pi over 2 to the right. Okay, now what I really am going to do here is I'm going to graph one cycle of this particular function, without the phase shift. And what that will look like, it'll start at 0. At pi over 2, it'll hit 1, because this is a sine curve. And then back to 0, back to negative 2. Did I say 2 or 1? It hits 2, and then 0, and then negative 2, and back to 0. So if I sketch this in, it's going to look like this. And that is one period of the graph y equals 2 sine of x. Now, if I'm going to phase shift it, that means this whole thing is going to shift to the right pi over 2 units. What's nice about this graph is that pi over 2 is one of the markers on my x-axis. So if everything shifts to the right pi over 2 units, I need to add another critical point here. And so the labels on this, again, if this is 1 pi over 2, this will be 2 pi over 2, which reduces, 3 pi over 2, 4 pi over 2. This one will be 5 pi over 2. So I'm going to add that in, 5 pi over 2. And then what I'm going to do, I'll do this in blue, I'm going to take each point. So this point will shift to here. This point will shift to here, to pi. Pi at 0 will shift to the right. This one down here shifts to the right, and then this shifts to the right. And when I sketch it in, it's going to start here, go up, come back to 0, down, and finish. And this one is y equals twice the sine of x minus pi over 2. Remember, in our horizontal shifts, we always go the opposite way of the sign in the binomial. Okay. Now, I don't have to do anything else. One period is that blue graph. It does not have to start at the origin or at the y-axis. Keep that in mind. It is simply one cycle. Okay, so this graph, y equals the negative cos of 3x plus 1. My angle here is represented by 3x. And what I will do is list over here my amplitude, which is a 1, but remember it's reflected because of the negative. So this is going to be reflected in the x-axis. I'm just going to put that in parentheses. My frequency is 3, which means then that my period will be 2 pi divided by 3. Then my vertical shift will be up 1 unit. Okay, so once I have those defined, I can go in and draw my axes. What's nice about graphing one period is that you're always, because the cosine curve takes 4 full quadrants to repeat, you're always going to have those 4 marker points on your x-axis. What will change is how we label them. Okay, now that will be determined by the period. The period is where the graph ends. And so this mark right here is going to be 2 pi over 3, which happens to be 120 degrees. Now let's think about this, okay? If it takes normally 360 degrees for a full graph, and I need to fit 3 of them in, if you divide 360 by 3, you get your 120. So that's that. The 2 pi over 3 is the radian measure for 120. Okay, now let's take this a little further. If I take 120 and I divide that into the 4 quadrants, each quadrant will get 30 degrees. Okay, but keep in mind, this has to be in radians. So you could do this and then change your degree measure into radians. 30 degrees is pi over 6. Okay, now that's one way to do it. The other way to do it is to say I have 2 pi over 3 and I want 1/4 of that for my first quadrant marker, because this is where it ends and I need to divide it into 4. So if I multiply this by 1/4, what I will end up with is 2 pi over 12, which will simplify 2 pi over 6. Either way, I'm going to get pi over 6 right here for my first quadrant critical point. Now, what you need to understand is that there's 4 critical points. The first one is 1 pi over 6. That's a 3. And this one here will reduce 2 pi over 2. And this one, the 4/6, will reduce to your 2 pi over 3, which I already knew. Okay, what I'm going to do is place these labels on my x-axis. So here will be pi over 3 and then pi over 2. Now I could have done the same thing here with my 30 and said this will be my 30, my 60, my 90, and my 120. And then I could have converted each of those degrees into its radian measure. It really depends on what makes more sense to you. I'm going to encourage you to do it in radians, only because as you move on through your math careers, that's how we're going to do it. But for now, all you really need to be able to do is get these 4 points labeled. Now, cosine typically will start at 1. However, because of this negative, it's going to be reflected in the x-axis. So the cosine curve would actually start at -1, and then it would hit 0, and then it would hit 1, and then it would hit 0, and it would end at -1. So it's going to look like this. Okay. Thing is, there's a vertical shift. So once you have it graphed with the amplitude and the reflection and the frequency, then go in and do your vertical shift. If there's a phase shift and a vertical shift, I always save those. I like to get a starting point so that I have a graph of reference before I do any shifts, either phase or vertical. Every one of these points now is going to just move up 1 unit. So I will do that piece in red. So this one will go to here. Instead of 0, I'll be going through 1. At pi over 3, instead of 1, I'll go through 2. And then here, I'll go through 1 and 0. So it's going to look like this. And this is my final image, which is y equals negative cos of 3x plus 1. Okay? Okay, so as we continue through, we're going to look at a lot of examples. Tomorrow what we're going to do is look at graphing over an interval versus graphing one period. Okay? And trust me when I tell you, graphing one period is way easier. A lot less to figure out. Sometimes the questions are as simple as this. We're given this function. What is the period of the graph? And so because I know that the period is equal to 2 pi divided by the frequency, and I know from here the frequency is 3, my period would be 2 pi divided by 3. Okay? And that's what I would report. Sometimes the graph could look like this. This is a little different because the frequency is written in a way that we're not typically used to. But in this particular case, if they ask for the period, keep in mind the period is equal to 2 pi divided by the frequency. And in this case, the frequency is pi over 2 because the frequency always is the multiplier on the x, on the angle. So because the frequency is pi over 2, what I will do is take 2 pi and divide it by pi over 2. And of course the complexity can be fixed by taking 2 pi and multiplying it by the reciprocal of the denominator, which is 2 over pi. And what happens is pi's cancel, and you end up with a period of 4 radians. Because that is what the x-axis is always labeled in. Okay? All right. So as we go through and look at examples, hopefully you'll have your notes to refer back to, and this will all be very simple.